Advanced Objects. Advanced Objects Introduction. Remember, objects in JavaScript are containers that store data and functionality. In this lesson, we will build upon the fundamentals of creating objects and explore some advanced concepts. So if there are no objections, let's learn more about objects. In this lesson, we will cover these topics. How to use the this keyword, conveying privacy in JavaScript methods, defining getters and setters in objects, creating factory functions, using destructuring techniques. Instructions: look over the code in main.js to see examples of the object-related concept covered in this lesson. Then click Next to get started on learning these concepts. Okay, so we see a bunch of objects here. We see an object, a function object here. It's taking in some variables. We see another object here with this in front of it, this underscores in front of name, robot capacity, and so on. And we have set robot capacity, new capacity. Okay, so there's the function here. This looks to be another function here if type of new capacity is number. Okay, so we're going to learn a little bit about this as well, this get and set here. All right, let's go to the next lesson. The this keyword. Objects are collections of related data and functionality. We store that functionality in methods on our objects. Const goat equals, and it opens up an object with diet type being a string of herbivore and make sound being a console.log of ba. So the make sound is a method within the goat object. In our goat object, we have a make sound method. We can invoke the make sound method on goat. It would be like this: goat.makeSound, invoke it, and that will print BAAA. Nice. We have a goat object that can print ba to the console. Everything seems to be working fine. What if we wanted to add a new method to our goat object called .diet that prints the goat's diet type? Const goat, and it opens up an object. Diet type is herbivore. It has the make sound method, and now we have a diet method which console.logs diet type. And we're doing goat.diet, so we're getting the diet method, and the output will be a reference error. Diet type is not defined. That's strange. Why is diet type not defined even though it's a property of goat? That's because inside the scope of the diet method, we don't automatically have access to other properties of the goat object. Here's where the this keyword comes to the rescue. If we change the diet method to use the this, the diet works. So the const goat object, and we see the difference is in the diet method, we're console.logging this.diet type, and when we invoke that method, the output will be herbivore. The this keyword references the calling object, which provides access to the calling object's properties. In the example above, the calling object is goat, and by using this, we're accessing the goat object itself, and then the diet type property of goat by using property.notation. Let's get comfortable using the this keyword in a method. Instructions. Let's create a new object to practice using this. In main.js, there is an object robot. Add a property of model and assign to it a value of a string with 1e78v2. Add another property, energy level, and assign the value of 100. So we need robot, and there already is an object robot, so we just need to add these properties, which is model, and we know that is that string here. I'm going to just copy it, paste it in, and we also have a property called energy level, and that will be 100. Let's run that. That worked. Let's head down to the next one. Inside the robot object, add a method named provideInfo. Inside the body of provideInfo, return the following string by using interpolation. I am model, and my current energy level is energy level. Replace model and energy level with the calling object's model and energy level property. Remember, to get the access to the calling object's properties inside a method, you have to use the this keyword. So now we need to make a method. So we'll make a method called provideInfo. And inside provideInfo, we need to return the following string. So let's return, and we could just, let me put it in parentheses, and here's the string that we need to return. We'll use backticks for string interpolation, and we I am, and then model has to be the backticks. Open that up, and this dot model. We'll do a space, and my current energy level is another string interpolator here. It'll be this dot energy level. And let's see if this is working. Let's run that. That did work. Now to check .provideInfo has access to the internal properties of robot. Log the result of calling provideInfo method on robot to the console. That's written a little poorly, but it wants us to invoke the .provideInfo method and log it to the console. So outside of this, we will console.log, and then we will invoke the method, which was robot.provideInfo, and invoke it. And let's run that. That looks right. I am, and that's the model number, and my current energy level is 100, which is right there. Perfect. Arrow functions and this. We saw in the previous exercise that for a method, the calling object is the object the method belongs to. If we use the this keyword in a method, then the value of this is the calling object. However, it becomes a bit more complicated when we start using arrow functions for methods. Take a look at the example below. We have the constGoat object, and we have a arrow function in there where diet is. And it's console.logging this.diet type, and when we invoke that, it actually prints undefined. In the comment, you can see that goat.diet would log undefined. So what happened? Notice that the .diet method is defined using an arrow function. Arrow functions inherently bind or tie an already defined this value to the function itself that is not the calling object. In the code snippet above, the value of this is the global object, or an object that exists in the global scope, which doesn't have a diet type property and therefore returns undefined. To read more about either arrow functions or the global object, check out the MDN documentation of the global object and arrow functions. The key takeaway from the example above is to avoid using arrow functions when using this in a method. Instructions. Currently, the checkEnergy method is not producing the correct output because it is using arrow function syntax. Refactor or change the method to use a function expression. You can write the function using either longhand or shorthand format. After refactoring the method, notice that checkEnergy has access to the other internal properties of the robot object. So we just need to change the syntax. We see we have checkEnergy, and it's pointing to this anonymous arrow function. We want checkEnergy to be a function, and we don't need an arrow, so now we have a method, and I think that's what they were asking for. Let's run it. That works. Let's move to the next lesson. Privacy. Accessing and updating properties is fundamental in working with objects. However, there are cases in which we don't want other code simply accessing and updating an object's properties. When discussing privacy in objects, we define it as the idea that only certain properties should be mutable or able to change in value. Certain languages have privacy built in for objects, but JavaScript does not have this feature. Rather, JavaScript developers follow naming conventions that signal to other developers how to interact with a property. One common convention is to place an underscore before the name of a property to mean that the property should not be altered. Here's an example of using underscore to prepend a property. Const bank account equals an object, and there's an underscore before the word amount, and it's 1,000. In the example above, the underscore amount is not intended to be directly manipulated. Even so, it is possible to reassign underscore amount. Bank account dot underscore amount equals, and then you could reassign whatever value you would like. In later exercises, we'll cover the use of methods called getters and setters. Both methods are used to respect the intention of properties prepended or began with the underscore. Getters can return the value of internal properties, and setters can safely reassign property values. For now, let's see what happens if we can change properties that don't have setters or getters. Instructions. Below the robot object, reassign the underscore energy level property to high. So below robot, that ends here, we will redefine robot dot underscore energy level equals high. And let's run that. That works. Now take a look at the new recharge method in robot. Recharge will add 30 to underscore energy level. What will happen now that energy level isn't a number? Call recharge on robot to find out. Let's do that here. Robot.recharge, and we will invoke that function. Let's run it. Recharge energy is currently at high 30%. Notice that a funky string is printed to the console. This is known as a side effect of type coercion. No need to worry about what this means for now, but it's important to understand that you can cause unwanted side effects when mutating objects and their properties. And we can move to the next lesson. Getters. Getters are methods that get and return the internal properties of an object, but they can do more than just retrieve the value of a property. Let's take a look at a getter method. We have a const person, and it's an object, and there is a get inside there. So get full name as a function, it opens up, and we have an if statement in there returning this.first name and this.last name. And when you print the full name here, it says John Doe, which is the first name and last name. Let me leave this in. Notice that in the getter method above, we use the get keyword followed by a function. We use an if-else condition to check if both first name and last name exist by making sure they both return truthy values, and then return a different value depending on the result. We can access the calling object's internal properties using this. In full name, we're accessing both this.first name and this.last name. In the last line, we call full name on person. In general, getter methods do not need to be called with a set of parentheses. Syntactically, it looks like we're accessing a property. Now that we've gone over syntax, let's discuss some notable advantages of using getter methods. Getters can perform an action on the data when getting a property. Getters can return different values using conditionals. In a getter, we can access the properties of the calling object using this. The functionality of our code is easier for the developers to understand. Another thing to keep in mind when using getters and setter methods is that properties cannot share the setter name as the getter-setter function. If we do so, then calling the method will result in an infinite call stack error. One workaround is to add an underscore before the property name like we did in the example above. Great, let's go getter. Instructions. In Robot, create a getter method named energy level using the get keyword. Leave function body blank for now. Let's see exactly how they did it. I know we used get and then the function. That's all that's going to happen. It's just the get keyword. So get, and the function they want is called energy level as a function, and all it'll do now is have a blank body. Let's run that and see if we did it properly. We did. Inside the getter method, add an if statement to check if this.energyLevel is a number using the type of operator. If that condition is truthy, return my current energy level is energy level. Replace energy level with the value of this.energy level. Make sure you return the string and not logging it to the console. Make sure you are returning the string and not logging it to the console is what they mean there. So we'll start with our if statement in the body here. It wants us to if this.energy level is a number. So they want us to use the type of operator, and then this._energy level, camel case, is triple equal to number as a string is what should return from there. So let's take a look if we did that right, and what else is here. If that condition is truthy, okay, so return my current energy level is energy level and replace the energy level. So we want to return a string, and we'll return with backtick, so we could do string interpolation there. My current energy level is, and then we want the energy level interpolated this._energy level. And let's see if that's working. Great, that looks right. And let's move on to the next one. If this.energy level isn't a number, it could be that the energy level property was altered. Let's add a default return statement for when such a scenario arises. Add an else statement that returns system malfunction, cannot retrieve energy level. Okay, so we have our if. The if statement ends here. We write else, and we return. And I'm just going to copy this string right in there. And let's run it. That works. Log the result of calling the getter method energy level on robot to the console. Notice that the method will return a formatted response rather than accessing a property. All right, so when they call the getter, let's make sure there's nothing to it here. Yep, it's just the same as it used to be. It just has get in front of it. It has a keyword in front. So we're just going to do robot.energy level. I'll head back down. Log the result of calling it. So console.log. And then we have robot.energy level. And we need to invoke that. Let's give that a shot. Oh, I see. See, after full name, you don't have to invoke the function on the getter method. Okay, let's get rid of that and run again. That's it. So when it says get, we will not invoke those functions. That's what get will do for us. All right, next lesson. Setters. Along with getter methods, we can also create setter methods, which reassign values of existing properties within an object. Let's see an example of a setter method. We have const person, and it opens an object, and inside of there is set. It's set age, it takes in new age, And in there is an if statement, if type of new age is triple equal to number, this dot age equals new age, so that updates the age. If it's not equal to a number, it's going to console.log, you must assign a number to age. Notice that in the example above, we can perform a check for what value is being assigned to this dot age. When we use the setter method, only values that are numbers will reassign this dot age. There are different outputs depending on what values are used to reassign this dot age. Then to use the setter method. Person.age equals 40. Console.log person._age logs 40. Person.age equals a string saying 40. The console.log will say you must assign a number to age. Setter methods like age do not need to be called with a set of parentheses. Syntactically, it looks like we're reassigning the value of a property. Like getter methods, there are similar advantages to using setter methods that include checking input, performing actions on properties, and displaying a clear intention for how the object is supposed to be used. Nonetheless, even with setter methods, it is still possible to directly reassign properties. For example, in the example above, we can still set ._age directly. Person._age equals a string saying 45. Console.log person._age will print 45. Instructions. Currently, in Robot, there is a getter method for num of sensors, but no setter method. What if we need to add or remove some sensors? Let's fix that problem. Add a setter method named num of sensors using the set keyword. Provide a parameter of num, leave the function body empty for now. All right, so let's start on that. Here's our getter method. Let's get past that. Right here is where we'll do our set method, and it wanted to set num of sensors. The parameter in here is num, and let's run it. Great. There are a couple of things we should do in the setter method. Add a check to see if num is a number using the type of operator. Num should also be greater than or equal to 0. If both conditions are met, reassign this dot num of sensors to num. Okay, so we have some conditions we need to work with, and we have an add a check to see if num is a number, so we do that first. If type of num triple equals a string undercase number, that will come back as true. Num should also be greater than or equal to 0. Okay, so we're going to do double ampersand, and then num greater than or equal to 0. So if those two things are met in our if statement, we want to reassign this dot underscore num of sensors, and that'll just be set equal to num, and that will update our num of sensors. Let's run that, make sure that's right. It is. Now add an else that logs pass in a number that is greater than or equal to 0 to the console. So we have our if statement that ends right here. We'll say else, and in that block we will return, are we returning or console logging? No, it logs. So console.log. We don't need to do string interpolation here, so just regular quotes is fine. I'm going to copy it in and run that. Great, that's working too. Let's use the num of sensors setter method on robot to assign num of sensors to 100. Okay, so we want to use the setter method. Let's see how they've used it before. We see here a set age. So person.age and then just equal to whatever we want it to be equal to. Okay, let's do that. This would be robot dot num of sensors is equal to 100 is what they want there. Let's run that and see if we did that right. We did. To check that the setter method worked, console.log robot.num of sensors. Okay, so after that, I will console.log robot.num of sensors. And we see we have 100 sensors on that robot now. So we'll go to the next lesson. Factory functions. So far, we've been creating objects individually, but there are times where we want to create many instances of an object quickly. Here's where factory functions come in. A real-world factory manufactures multiple copies of an item quickly and on a massive scale. A factory function is a function that returns an object and can be reused to make multiple object instances. Factory functions can also have parameters, allowing us to customize the object that gets returned. Let's say we wanted to create an object to represent monsters in JavaScript. There are many different types of monsters, and we could go about making each monster individually, but we can also use a factory function to make our lives easier. To achieve this diabolical plan of creating multiple monsters objects, we can use a factory function that has parameters. Const monster equals, and here are the parameters, name, age, energy source, catchphrase. It's a fat arrow function, and then there is the body of it, and it returns an object with the name being name, age, energy source is energy source, and a method called scare that console.logs the catchphrase. In the monster factory function above, it has 4 parameters and returns an object that has the properties name, age, energy source, and the scare method. To make an object that represents a specific monster like a ghost, we can call monster factory with the necessary arguments and assign the return value to a variable. Const ghost equals monster factory, ghoulie 251, ectoplasm, boo. And then ghost.scare, calling that method from ghost, will return boo. Now we have a ghost object as a result of calling monster factory with the needed arguments. With monster factory in place, we don't have to create an object literal every time we need a new monster. Instead, we can invoke the monster factory function with the necessary arguments to take over the world or make a monster for us. Instructions. Instead of making individual robots like we've been doing, let's make a factory function to make robots as we please. Create a factory function named robot factory that has 2 parameters, model and mobile. Let's create a factory function first. So const robot factory, and it's going to take in 2 parameters, that's model and mobile, and then fat arrow function to the body. Make the function return an object. In the object, add a key of model with the value of the model parameter, add another property that has the key of mobile with the value of the mobile parameter. So we'll start with that. So we're going to return an object, and inside that object, we're going to have a model. The key will be model, and we're going to return the model we're getting as the argument up here, and then mobile, and we'll have the mobile that we're getting as the argument up here. And what's next here? Then add a method named beep without a parameter that will log beep beep to the console. Okay, so we will have a method here. It'll be called beep. It doesn't take a parameter. It just console.logs beep boop. And let's see if we did that all right. That's right, great. Use your factory function by declaring a const variable named tin can. Assign to tin can the value of calling robot factory with the first argument of p500 and the second argument of true. Okay, so we will have a const named tin can, and that's equal to robot factory, and we're going to pass in this right here, that's p500, and then the Boolean value true. And let's run that. That worked. Let's now check what tin can do. Call .beep on tin can. Okay, so under this, tin can .beep. And let's run that. Beep boop is printed to the console. You should see beep boop printed to the console, which means the factory function produced a robot object. Play around with tin can and check for other properties. We sure could do every single one of these. So let's just do one more. Tin can dot model, and I'll console log that. So console dot log tin can model. Run that. We see it's the P500. Let's go to the next lesson. Property value shorthand. ES6 introduced some new shortcuts for assigning properties to variables known as destructuring. In the previous exercise, we created a factory function that helped us create objects. We had to assign each property a key and value, even though the key name was the same as the parameter name we assigned to it. To remind ourselves, here's the truncated version of the factory function. So there's the const monster factory. It takes in name and age, and it returns an object with name being name and age being age. Imagine if we had to include more properties, that process would quickly become tedious. But we can use a destructuring technique called property value shorthand to save ourselves some keystrokes. The example below works exactly like the example above. Const monster factory takes in name and age, and it returns name, age. There's no longer name being name and age being age. Notice that we don't have to repeat ourselves for property assignments. Instructions: use the property value shorthand and refactor the factory function in main.js. Okay, well that should be pretty simple. We need to get this out of here and this out of here. We just have, just like they did, model mobile, just like they had name age. This would still have to do what it's doing, I imagine, so let's run this. There it is. We'll move on to the next lesson. Destructured assignment. We often want to extract key value pairs from objects and save them as variables. Take, for example, the following object, const vampire equals, and it opens up an object and has a name of Dracula, residence, Transylvania, preferences is an object itself. It has, during the day, it wants to stay inside. During the night, its preference is to satisfy its appetite. If we wanted to extract the residence property as a variable, we could using the following code. Const residence equals vampire.residence. Console.log residence prints Transylvania. However, we can also take advantage of a destructuring technique called destructured assignment to save ourselves some keystrokes. In destructured assignment, we create a variable with the name of the object's key that is wrapped in curly braces and assign to it the object. Take a look at the example below. Const residence, that's in curly braces, equals vampire. Console.log residence, that prints Transylvania. Look back at the vampire objects property in the first code example. Then in the example above, we declare a new variable residence that extracts the value of the residence property of vampire. When we log the value of residence to the console, Transylvania is printed. We can even use destructured assignment to grab nested properties of an object. Const day, and that's within curly braces, equals vampire.preferences, console.log day will print stay inside. Instructions. Use Destructured Assignment to create a const variable named functionality that extracts the functionality property of robot. If you need a reminder on how to use Destructured Assignment, review the example in the narrative or check the hint. Okay, so we want a const variable named functionality, so const functionality that will equal the functionality property of robot. So robot dot functionality. Oh, we don't need to do that. So we're going to destructure it off of that. So functionality is at the first level, right here. If we were where they were in that last one, we need to go a little further, like vampire dot preferences to get to day because of this. Vampire dot preferences, and then there's day. So what we want is on the first level here. It's robot.functionality. So we can just destructure it by taking functionality and putting these curly braces around it. Let's run that and see if it works. Yes, it worked. All right, number 2. Since functionality is referencing robot.functionality, we can call the methods available to robot.functionality simply through functionality. Take advantage of this shortcut and call the .beep method on functionality. Okay, functionality has a .beep method, so functionality .beep, and we'll run that. And it says up here, beep boop, which means it worked. Let's move on to the next lesson. Built-in object methods. In the previous exercises, we've been creating instances of objects that have their own methods, but we can also take advantage of built-in methods for objects. For example, we have access to object instance methods like .hasOwnProperty, .valueOf, and many more. Practice your documentation reading skills and check out MDN's object instance documentation. There are also useful object class methods such as object.assign, object.entries, and object.keys, just to name a few. For a comprehensive list, browse MDN's object instance documentation. Let's get acquainted with some of these methods in their documentation. Note, you will see errors as you work through this exercise, but by the end, the errors will be fixed. Instructions. In main.js, there is an object, robot. We'd like to grab the property names, otherwise known as keys, and save the keys in an array which is assigned to robot keys. However, there's something missing in the method call. Find out what we have to include by reading MDN's object.keys documentation. Okay, first let's see exactly where they're saying this. There's an object called robot. We'd like to grab the property names. Okay, so object.keys, that's right here, and something is missing from object.keys. Let's take a look at what that is. Okay, object.keys, and then we have to pass the object in. Okay, let's head back and pass in the object we want, which is called robot, and run that. That works. And like it said, you're going to have a lot of errors in here, but that's what they wanted. Let's go to number 2. Object.entries will also return an array, but the array will contain more arrays that have both the key and value of the properties in an object. Declare a const variable named robot_entries and assign to it the entries of robot by calling object.entries. Find out how to use object.entries on the MDN documentation. Okay, so the next thing we want to do is declare a const named robot_entries. Oh, declare robot_entries below this line. So const robot_entries. All right, so we have that, and we want to set it equal to object.entries. So let's see how object.entries works. Let's see what we have here. This isn't displaying very well, and they put object.entries in a for loop. That's not really how we want to demo this. Let's see if they have more examples. Yeah, here are all the examples. Okay, so they have a const object equal to an object with foo being bar and baz being 42. Console.log object.entries, and then you pass in the object. It makes an array of arrays with the corresponding key value pairs. Okay, so that's what it's going to do if we pass in an object. And we just need to assign it to the entries of robot. So we're going to have robot here. Okay, so object dot entries, and we're going to pass in robot and run that. That worked, and we could see that we have these key value pair arrays now being model and sal. So the array at 0 and then at 0 again would be model, and the array at 0, 1 would be sal 1000. Let's go to number 3. Now, what if we want another object that has the properties of robot, but with a few additional properties? Object.assign sounds like a great method to use, but like the previous examples, we should check object.assign documentation at MDN. Declare a const variable named newRobot. NewRobot will be a new object that has all the properties of robot, and the properties in the following object. Laser blaster, true. Voice recognition, true. Make sure that you are not changing the robot object. Okay, so it wants us to use object.assign. Let's set this up first. And so new robot, that's this. So const new robot equals object.assign. And then let's see what we need to do here in the documentation. Yes, okay, so yeah, this looks like it'll take in 2 different objects. The first object is the object that we're going to assign the second object to, but if they share, say, this B here, it will be overwritten. So this has B4, and the B that's in there was replaced by it. It kept its A1, it replaced its B4, and it added C5. So object.assign, we have our target. So that's where we want to add the new assignment to, and then we need a object actually put in there. Let's do it. So object.assign. The first thing we'll need is robot. And the second thing we need is an object with everything that we want to put in there, which is this. And we could define this somewhere else, but this should work just fine too. And let's just run it, see if we did it right. All right, so the robot object should not be changed, and we saw, yeah, it says that right here. So I missed that. Okay, so it can't be changed. So I no longer want to have robot here because I don't want robot to change. So we're actually morphing this up here. That's what we don't want to be doing. I'm just going to put an object in there. And we will assign robot, comma, and then this object as well to new robot, and in there should be all of that. Let's see if that works. That does work. Okay, great. So the difference was when I put robot here, it was assigning things to robot. We want a new robot with a copy of robot in it, plus these new features. So we gave an empty object here to be filled with robot and this as well. So that worked great. Let's move on to our next lesson. Review. Congratulations on finishing advanced objects. Let's review the concepts covered in this lesson. The object that a method belongs to is called the calling object. The this keyword refers the calling object and can be used to access properties of the calling object. This keyword refers to the calling object. Methods do not automatically have access to other internal properties of the calling object. The value of this depends on where the this is being accessed from. We cannot use arrow functions as methods if we want to access other internal properties. JavaScript objects do not have built-in privacy. Rather, there are conventions to follow to notify other developers about the intent of the code. The usage of an underscore before a property name means that the original developer did not intend for that property to be directly changed. Setters and getter methods allow for more detailed ways of accessing and assigning properties. Factory functions allow us to create object instances quickly and repeatedly. There are different ways to use object destructuring. One way is the property value shorthand, and another is destructured assignment. As with any concept, it is good to learn how to use documentation with objects. You are ready to start leveraging more elegant code for creating and accessing objects in your code. And this lesson is all finished. You could do some extra work here if you'd like, and I'm going to see what is up next. And up next